We'll proceed in vector, summation, and integral calculus. Vector, summation, and integral calculus. How to calculate a entity, how to solve a problem by dividing problem into n different parts and then solve part by part and then add it. All the n parts, someone must add it. If someone is adding all n parts, then it is called summation. Dividing the problem into n different parts and solving one single part. Okay, if I solve one single part, then that part is called ith part. Means if I divide my big problem into n different parts, if I divide my big problem into n different parts, then each part, I say ith part, where I starts from 0 to n. If I solve in part, the solution of in part is considered Si. Solution of ith part is Si. The net solution is summation I equal to 1 to n. Si. S is subscript. Bottom right side beneath, just write I. Okay, what is the precondition for this? Preconditions are the biggest precondition dividing my problem into n different parts. This is considered as IID, identically independent distribution. Identically independent distribution. Like consider that I am trying to calculate area of a shape. I am trying to calculate area of a shape. Okay, I am trying to calculate area of a shape. What is the shape? The area of a shape is like this. What is this? This is the area of the shape. One side is flat and other side is like this. Can you calculate area of this shape? Okay, I can calculate the area of the shape. How we can calculate? I divide this area into n different parts. I'll chop this x-axis up. I'll chop this x-axis into n different parts. Okay, consider this is the ith part. This is the first part, second part, ith part. This is ith part. If I draw a vertical line, ith part beginning, ith part end. If I draw a line like this, it will go and hit this place. I call it area number I. This is area number I minus 1. This is area number I plus 1. This is area number I. What you want? I want this area. This area is same as summation I equal to 1 to n area of the ith section. Means I have divided this area into n different parts. If I calculate part by part and then add it, it will be area. How I can be sure that I can divide my problem into n different parts? This is only possible if all the parts what we are talking, they are identical. They are identical, independently distributed, but they are not identical here. They are identical here. Here, x-axis I have divided into n identical parts. X-axis I have divided into n identical parts. And these identical parts, if I calculate the area, all the parts are independent to each other. They are not dependent upon each other. What do you mean? They are not overlapping each other. If I can divide my problem into identical independent fashion, okay, someone would say that it may not be identical. If it is if it is not overlapping, that is also all right, but it will be difficult to manage. Someone would say, I'm dividing into n different parts. That is, I'm dividing into n. I'm dividing it up. I'm dividing into n different parts. But all part is not required that they will have same width. This part, this part, this part, they will have different width. In that manner, all area what we are calculating, the bottom is not, but they are not overlapping with each other. They are independent. They are independent to each other. Then it's also be okay. It's okay, but it will be very difficult to manage though. Okay, now I can simply write summation I equal to 1 to n. Summation I equal to 1 to n area of the ith part. All area are non-overlapping, they are independent to each other. If they are non-overlapping, independent to each other, then I can calculate area, I can sum it and I can get the full area. Okay, if okay, where is the where there are three terms. One is identical, one is independent, and identical, independent, and distribution. So it is distributed. Independent, they are independent, they are not overlapping each other. Identical. If it is identical, then I can rewrite it summation I equal to 1 to n fx x. This is x axis. If this is x axis, x starts from 0 and it goes along. Okay, at any x that belongs to any section I is a section number 1, 2, 3, 4, ith section and nth section. Section number I, summation I equal to 1 to n, section number any I, and then after that it is function over x belongs to the ith section. This is ith section. Which x you want? Anywhere. I at the beginning and I at the end. Ith section at the beginning. Ith section at the end. Anyway. Anyway. Any x I can take in bit. Fx in the ith section. Delta xi. This is the delta xi. This delta xi are same if it is identical. Now I can write in a very simple manner. Summation I equal to 1 to n. I equal to 1 to n fxi delta xi. Okay, delta x is the width of the ith section. But someone can say it is not required that delta x for all the section will be same. Yeah, it is possible. Then also it will work. But in that manner, it will be difficult to manage it through the simple summation equation. Okay, how it will be difficult? It will be difficult in a manner. Consider, okay, I'll take another example. Consider I have n number of coins. I have n number of coins. And n number of coins, I'm trying to solve the problem, some problem. What is expectation of getting how many head I'll get? If I drop n number of coin, how many head I'll get on an average? Okay, all coins have probability distribution. Probability distribution means each coin have the probability of getting head as 0, head as 1. So there are two bar of probability distribution in X as far as getting head or tail is concerned. Two lines will be there. Okay, now consider that each coin are same. Each coin are same, but they may not be fair. In a sense, getting probability of head may not be zero point 0.5. It may be different than zero point 0.5. But they are identical in the sense that all coins they are same. They are same. But they are different. They are but each coin is a biased coin. But all coins are same. If one is biased to an extent that getting head probability is zero point 0.6, then all are zero point 0.6 one. All. Okay, what I am saying, if they are not identical, if they are identical, and since they are independent, their outcomes are independent to each other. If I find out for one average of getting head, in average probability of getting head in one coin, then I can multiply by n because all are same. If all are not same, they are independent, true, but they are not identical. They are independent, true, but they're not identical. If they're not identical, who has guts now? If n is 10,000, then for each coin he will calculate the getting the probability of head is how much, and then he will sum it. Get for each one. That's why we say identically distributed. So if I say it is identically distributed, then there it has many meaning. One meaning is that the way we are calculating the area fashion, the area calculation is same. If I compare through the coin. So it is required. Identically independent distribution is required. Here, but now the discussion what we are pursuing, very deep discussion we are pursuing. If I am distributing my problem is getting area. If I am distributing my problem into n different parts, then can I solve one particular part by vector? What is the area of this section? Area of this section is height by width. I know that. It is height by width. I know it. Can I do it through vector? Can I do it through vector? That is the question. Why you want vector? This is x-axis. This is y-axis. This is x-axis. This is y-axis. Okay. This is x-axis and this is y-axis. How to calculate area? Okay, to calculate the area, one concept is I'll divide x-axis into n different parts. If I do so, then I have one particular part. Then I'll multiply fx by that part. That is one way. Second way is I'll chop y-axis into n different parts, x-axis into n different parts. Then I have many sub area, rectangular area I am getting now. One rectangle means I chop x-axis into n different parts. Hope. And y-axis that is going from here to here to here, y-axis. Now I divide this into n different parts or m different parts, m for mountain. If I divide this from here to m different parts, I divide this to this into n different parts. I have m into n rectangles. Okay, if I take one rectangle, then it has a width of delta x and width of delta y. Width of delta x and width of delta y. Now how I can proceed now calculating the area? Someone can tell me. The concept is to divide the problem into n different parts. We are going through this way, dividing the problem into n different parts. Then how I can proceed? This is one area, but this may not be area. This may not be a rectangular area. This is rectangular area. I can simply say summation I equal to 1 to m, summation j equal to 1 to m, area of the ith jth section. This is the ith jth section. And the area is delta xi delta yj. This is the jth section I took because the concept is how I can solve a problem dividing into n part. So if it is area, then the natural solution is to divide x-axis and y-axis both into n different parts. Then this is ith section, this is jth section. This is I, this is delta x and this is delta y. Delta xi, ith section. Delta yj, jth section. This area is delta x, delta y. Now summation I equal to 1 to n, summation j equal to 1 to m. Delta xi, delta mj will give the area. But so how someone can proceed? Because this region does not have rectangle. Okay, we proceed in a concept called vector. We will take the help of vector to calculate the any area. Why we use area? Why we use vector? Vector has some inherent property. If I am trying to calculate the line length, what is line length? What is the line length of this? No way anyone can calculate the line length. Even someone is using calculus, no one can calculate line length of this curve. What is the length of this curve? No one can calculate. Okay, some wire media, someone can calculate the area, that is fx dx. Fx in algebraic formula dx from x1 to x2 will give the area. What is the line length? No one knows. Through calculus also we cannot, okay, I can chop this line, I can chop this line into n different parts, or this line had intersection on x-axis. I can chop this x-axis into n different parts. If I chop like this, then at any particular section in x, go and it hits here. If it hits here, then it forms a two arena. One arena is delta x and one arena is delta y. What is length of this section? Delta x whole square plus delta y whole square root. Then I'll proceed in that fashion. Summation I equal to 1 to n. Summation I equal to 1 to n. Okay. delta xi, ith section delta x whole square plus ith section delta y whole square root. This is the length of this section. Understandable, right? This is the length of this section. Now proceed. What is delta y? Delta y of the ith section. Delta y is associated with delta x. How it is? Because it has a formula. This formula is y equal to a square root of a square minus x square. If it is a circular, y equal to square root of a square minus x square. This is the a, that is the radius. This is how y and x are associated. If I know delta x, then I can assume what would be delta y. Delta y, what would be delta y? If I know delta x, what is delta y by delta x? I don't know. What is delta y by delta? What is delta y by delta x if delta x tends to 0? Yeah, dy by dx. Dy by d. What is delta y if there is delta x? Okay, I don't know. What is delta y if there is delta x? I don't know. Okay, what is delta y by delta x? I don't know. What is delta y by delta x? That also I don't know. Okay, what is delta y by delta x? Delta y by delta x means per unit of x is how much is the y. That is delta y by delta x. Okay, what is delta y? If there is delta x, for this delta x, how much is the delta y? That is delta y. What is delta y by delta x? Per unit of x, difference in x per unit, 1 unit, brings how many difference in y? That is delta y by delta x. Okay, I am saying this length, if this is delta x, if I go up and hit here, then this curve, if I try to see, then if I consider this is a straight line, think for some time. Or if it is not a straight line, this curve have two sections in x and y. If I go down, this is delta x. But if I take this vertical section of this curve, then this is delta y. If I take the length of this curve, considering this is a straight line or connecting these two end points as a straight line, then that length will be delta x whole square plus delta y whole square root. Delta x is how much? I know delta x is how much. If I divide this into n part, delta x is, if this length is 2a, 2a by n is delta x. What is delta y? I don't know. What is total length? Total length. If I add all the section, then it becomes total length of this curve. That is summation I equal to 1 to n square root delta xi whole square plus delta yi whole square. Delta x is how much? Okay, I can estimate. How much is delta y? I don't know. How much is delta y? I don't know. Do you know delta y by delta x per unit in x is how much in y? I don't know. What about delta y by delta x if delta x tends to 0? What do you mean? N tends to infinity. Okay. N tends to infinity. Then delta y by delta x tends to, that is dy by dx. Yeah, I know dy by dx. Okay, you know dy by, yeah, I know dy by dx. How much it is? Y equal to square root of a square minus x square. Dy by dx is minus x by a square root of a square minus x square. How I can use it? Okay, how I can use it? Then summation I equal to 1 to n. Summation I equal to 1 to n. And then a square root delta x whole square plus delta y whole square. Delta x I can take it out. It becomes now square root 1 plus delta y by delta x whole square into delta x. If delta x tends to 0, n tends to infinity, then 1 plus dy by dx whole square of square root into delta x. Delta x belongs to ith section, delta x. I can proceed like this. But this is not considered as a natural way. Okay, this is the line length you calculated. Now tell me how you calculate the area. Means area of one particular. If I chop y section, y axis into m different parts, then how you calculate? Then it is easy. Calculation of area, right? Yeah. Summation I equal to 1 to 1, summation j equal to 1 to m, delta xi into delta yj. Because it is a rectangle, it will be multiplication of delta x and delta y. Then add for all the sections. But it is not this is a curved line. Then I don't. Okay, there are scenarios where we start hitting the boundary here or there, or then we use higher level technology to solve it. That comes as a vector. Can I solve, if I divide my problem into n different parts, can I solve any particular part problem through vector. Yes, that is more natural way. What is more natural way? What I am saying more natural way is if I am trying to calculate, if I am trying to calculate, okay, if I divide 0 to n into n different parts, what I am trying to say, rather than dividing x-axis into n different parts, let divide this into n different parts. Okay, if I divide this into n different parts, let's take this is the ith part. What is the vector representation of this ith part? If I know vector representation of this ith part, then I can calculate the length of this vector. If I know the length of this vector, then I can add for all, I get the length. Or if I divide x-axis into n different parts, ith section I'll take it and go up like this, hit it here. Whatever I am hitting, this is a curved line. What is the vector representation of this curved line? If I get vector representation of this curved line, then if I calculate the magnitude of that vector, I'll get this length. Then I'll add for all, or I'll add for all. Okay, vector is an entity. Vector is an entity which has some inherent property. What is inherent property? If vector represent a straight line, vector do not represent a curved line. Vector always represent a straight line. If I have a vector that is connecting point x1 y1 to x2 y2, there is a vector representation of this. What is that? Y2 minus x2 minus x1 I plus y2 minus y1 j. That is the vector representation of this line. X2 minus x1 I plus y2 minus y1 j. What is the length of this point x1 means actually original question is what is the length of a line connecting x1 y1 to x2 y2? The length of line connecting x1 y1 to x2 y2. The length of the line that is connecting x1 y1 to x2 y2. Someone can find through Pythagoras and whatsoever. Okay, then it is solvable through vector also. Can get a vector that is connecting x1 y1 and x2 y2, that will be x2 minus x1 I plus y2 minus y1 j. Calculates its magnitude, you get the length. What I am trying to say, if I have a point here x1 y1 and there is a line like this and there is another point here x2 y2, okay, then what is the length of this? If I represent this point through vector and calculate the magnitude, I get the length. That's why you want to divide into n different parts. Calculate the vector representation of this curve line, and then calculate the magnitude. You get the certainly. What about the area of this? Then what you will do? What about area of this? What about area of this? Okay, if I represent through this as a vector, if I represent this through as a vector, and if I represent this through as a vector, then if I take cross product of these two, then it should give the area. This is in theory. Okay, vector has two inherent property. One property is if I have a vector representation, if I calculate the magnitude, if I calculate the magnitude, it gives the length. One thing, if I have two vectors, if I have two lines, if I have one line and I represent that line through vector, then if I calculate the magnitude of the vector, I get the length of that line. 2 points. If I have two lines, these are two lines. One line is a straight line and one is a curved line. If I represent this curved line through vector and if I represent this straight line through vector, if I take cross product of these two, it will give the area. But we have heard that cross product of two straight lines gives the area, that is the parallelogram. This is the new thing that is we have invented. If I represent this curved line through a vector and this line also through a vector, then if I take cross product of these two, as per the fundamental of vector, if I have two lines, what is the area in between this? If I have these two lines, what is area in between this? That is a question. What is area in between this? Okay, what area you want? I want area in between this. Okay, consider there is a line. that is going perpendicular to this line and it is connecting this. Consider what is area of this? What or if these two lines makes a parallelogram, this line and this line, they make a parallelogram. What is area in between this? What is area in between this? Then it forms a rectangle. If I say area in between this means this line and this line end point connected, I connect like this through parallel lines. This is rectangle. What is area in between this? This line from this point make a straight line that is parallel to this and connect like this. This is a parallelogram. That is the area. If I have a vector representation of this line and vector representation of this line, if I do cross product, it gives the area. What is length of this line? Represent this line through vector and calculate the magnitude, you will get the length of this line. What is area of this section? Represent this line through vector. Represent this line through vector. This point is origin. This point is x2, y2. This point is x1, y1. This vector is xi plus yj. This vector is x2i. This vector is x1i plus y1j. This point is x1, y1. This point is x2, y2. This is x1i plus y1j. This is x2i plus y2j. This line is. What is length of this line? The magnitude of x2i plus y2j. What is length of this line? The magnitude of x1i plus y1j. What is the area in between? Cross product of x1i plus y1j, cross product with x2i plus y2j. Whatever comes, it will come as a vector. Yeah, it will come as a vector. This is called area vector. Now I am representing whatever the new vector arrives, that is called area vector. If this is a plane, if these two makes a plane, area vector will be perpendicular to this plane. Okay. Now resultant is an area vector. What is area vector? If you calculate magnitude of the area vector, it will give you the area. Amazing, mind blowing. Okay, what are you trying to say? Concept is I am trying to find the area of this shape. Area of this shape I am trying to find out. Okay, if I take this as this vector, what is this vector? This vector will go along the I direction. This vector will go along the j direction. If I take the cross product of these two, I'll get the area. Certainly, I'll get the area. What are you saying? What is this? Consider I chop it into x part. I believe this is alright, understandable. If I want to calculate length of a line, a straight line, then to end point I'll get and I'll represent it through vector. And then I'll calculate the magnitude of vector, I get the length. If I have representation of two lines, if I want to calculate the area between two lines, if I want to calculate the length of a line, then that is the way. Represent line through vector and calculate the magnitude. How to calculate area of these two? Area. Area is a magnitude. Get the vector representation of this area and calculate the magnitude. Vector is amazing. Vector representation of a straight line. If I calculate the magnitude of the vector, I get the length of the line. If I have a vector representation of area, then if I calculate the magnitude of that vector, I get the area. If I have a vector representation of a volume, if I calculate magnitude of that vector, I get the volume. If I have a vector representation of a weight, if I calculate magnitude of that vector, I get the weight. Amazing, mind blowing. Can someone really believe this? If I have a vector representation called x2 y2 x2I plus y2j, x2I plus y2j, if I have vector representation like this, and I have x1I plus y1j, if I do cross product of these two, it will result in something that will be something I plus something j. Someone will say, oh, I know. That is the line. That is not the line. That vector represents area. x1I plus y1j cross product x2I plus y2j. How much it will be? I can write in a matrix x1, x2, y1, sorry, x1, y1, x2, y2. Okay, it will come at x1 multiplied by y2, x1 into y2, I cross j, k value, that is perpendicular to the surface. x1 into y2 k vector. Okay, and then this side minus x2 y1 k vector means x1 y1 x1 y2 minus x2 y1 bracket close k vector. What is this? Okay, I'm sorry, it did not come in ij. I was saying it came as a k vector. Someone would say, what is this? x1 y2 minus x2 y1 k vector. Oh, it says k vector, right? It is a straight line. But that vector is holding information of an area. What do you mean? If I calculate magnitude of that x1 y2 whole square plus x2 y1 whole square root, this will give the area between this. A vector represent something. If you see the vector x1I plus y1j, it is representing a straight line. x2I plus y2j, it is representing a straight line. I can do cross product of these two to bring a new vector that will be representing a area. If I calculate magnitude of it, it will give the area. Okay, now let's proceed. Now I am trying to find the area of this circular part that it has an intersection with x-axis. This is radius a whatsoever. I divide x-axis into n different parts, y-axis into m different parts. I have a rectangular region for the area. What is the area of this rectangular region? Then it is something delta xi cross delta yj. Delta xi cross delta yj. If I do cross product of these two, and then I'll take magnitude, certainly it is not going to give the area. Okay, there are many philosophies behind it. Anyway, it is not giving the area. Anyone can try. If delta xi cross product with delta yj, okay, what is the area? Then area is summation of I equal to 1 to n, summation of j equal to 1 to m, delta xi cross product delta yj. It will become delta x delta y. It will become delta x delta y. K vector. Okay, that is the area of this. But how I can proceed from here? There are some loci here where we are trying to calculate area. When we are trying to calculate area, we make sure that the two component what we are getting, the two components what we are getting, they should be independent to each other. Means delta x and delta y, when we are doing cross product, they should be independent to each other. They are not independent to each other. Delta y is tied with delta x. We will talk about this. Okay, anyway, we are in process of using parameterization is a concept that comes into the picture when we want to dissociate the relationship between two components. What is dissociation of relationship between two components? We will talk more on it. Probably it is not very clear now what I am trying to say. If I am trying to find area through variation in delta x and through variation in delta y, then I cannot go together. Delta x into delta y will give the area. Why it will not give the area? Because both side of the area, if I'm trying to calculate the area by multiplying this side and this side, they should be independent to each other as far as a vector is concerned. Means if I'm trying to calculate area of this and this line and this line should be independent to each other. Then only I'll get area underneath by saying P1 cross P2. But P2 vector, P2 vector, if I say P2 vector, it has a variation. Okay, I'll go a little bit more. What is P1 vector and what is P2 vector? If I'm trying to calculate the area, what is P1 vector and what is P2 vector? P1 vector, I know. Xi plus Yj is P1 vector. Sorry, X2I plus Y2j is P1 vector. What is this vector? X1I plus Y1j is this vector. Okay, is it the length vector? Yeah, this is the length vector. If you calculate the magnitude, you will get the length. Yeah, x2 square plus y2 square root is the magnitude of this. X1 square plus y1 square root magnitude of this. So these are length vector. If I calculate the magnitude, what about I have two? I have if what about if one of this line has to be represented by curved line? What about this? If they have to be represented through a curved line, now tell me what is the area. Okay, now what is the area? What is this line? Consider this line. The curved line is only from this point to this point. This is the curved line. Okay, there is a section in the curved line. How I can say show what I want. This is a curved line. Okay, this is a curved line. This is a curved line. What is the area between this and this? Don't know. Okay, if I describe this section as a vector, then as per the vector fundamental, if I do cross product of two vectors, it will give the area in between. Yeah, that is true. What is the vector representation of this? I know this is origin. Yeah, this is origin. This point is x1 comma y1. Then vector representation is x1 I plus y1 j. That is false. Okay. What about if this line is also a curve? This line is a curve. This line is a curve. What is vector representation of this line? Origin, and this is x2 y2, x2 I plus y1 y2 j. Wrong, because if I connect x2 y2 to origin by a straight line, that is a vector we are talking. Or if this is a line, if I connect x1 y1 to the origin through a straight line, this is the line we are talking, x1 I plus y1 j. It is a position vector, not the line vector. What about this? I have an area section that forms with this line and this line in between, or between this line and this line, where this line is also a curved line. This line is a curved line, this line is a curved line. In a curved line, the end point is x2 y2, here end point is x1 y1. I cannot say this line representation in a curved manner, it is delta, it is xi plus yj, because that will connect origin to this point straightforward, not like a curved manner. What is the curve equation for? We have talked about length vector. It's possible to represent this in a curve manner. Okay, to represent anything in a curve manner, if I want to if I want to find this area, then I have to do cross product of this vector and this vector. This vector is not a straight line. I'm just to show because I don't have any other thing that is a curve line. Okay, I should have another thing that is a curve line. That is the problem. Okay, so I have a curve line. What is area between these two? Why you are talking like this? Because we need to find area of a circle kind of thing. Okay, where the lines may not be straight. What is area between these two? Okay, what is the end point here? End point is x2 y2. X point is x1 y1. If I connect origin to x1 y1, this will be a straight line. If I connect x2 y2 with the origin, this will be a straight line. Then if I do x2 y2 cross x1 y1, this will give area in between the straight line, not between these two curves. How I can represent this curve through a vector? Okay, this is called algebraic vector. It will not be a straight line, then it will be algebraic vector means you keep changing x and y, you will keep changing this will be a set of vector where each vector is a tangent at every point on this line. This line has infinite points. Every point what is tangent vector, if I combine all tangent vector in one vector, that will become an algebraic vector, algebra, because it will be a variable vector. Then how I can represent, if this is x1 y1, this is origin. If it was a straight line, then it would have been x1 I plus y1 j. If I have a curved line, in this curved line, if I this is x-axis, then in curved line everywhere y by x is different. Everywhere. If it is a curved line, everywhere y by x is different. Not only that, everywhere dy by dx is different. Okay, y by x is different. Everywhere that is true, then dy by dx is also everywhere true. If it is a straight line, then y by x everywhere it is same. If this is x-axis, consider if it was a straight line. I believe this section to this section it is a straight line. Everywhere y by x is same. That is a number. But after that it makes a bend. Everywhere y by x is different. Means if I want to represent through a vector that is xi plus yj, it must be in a form of y by x, because y by x is variable. If I take out x, it becomes I plus y by x j bracket closed into x. That is same as xi plus yj. Okay. If I change y by x, not only y by, what is the curve line? What is the curve line? If I talk about a curve line, consider this is a curve line, okay? This is a LED light. So if I talk about this curve line, if this is a curve line and this is x-axis, if I take this as y, vertical is y, then this is x. Here y by x is different. Here y by x is different. Here y by x is different. Not only that, if I take any point and then draw a straight line, that will be a tangent line. Okay, everywhere tangent line is different. Here tangent line is like this. 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 Tangent means dy by dx. Dy by dx at any point it gives a slope of that tangent line, tan theta, not theta, tan theta. Everywhere tan theta is different. If it was a straight line, if it was a straight line, then everywhere y by x is same because theta is same. But if it is a curved line, everywhere theta is different. Okay, here theta is like this, here theta is everywhere theta is different. I can represent it through vector only when I address dy by dx. You can represent anything through algebra only when you tackle the independent component. Independent component must be addressed there. If I have a line where x is independent and y is dependent, I cannot represent a line through y because y is dependent. Can you represent only through x? Yes, it is possible only through x if x is independent. How it is? Okay, if I talk about the position vector, consider this line equation is y equal to x square. If this is the point, this is the point. If I connect through origin, these are called position vector. This position vector is xi plus yj, where y is dependent upon x. Then it will become xi plus x square j. I can represent this vector only through x, because x is independent component. Independent component must be there. If I this is the position vector xi plus x square j. What about the line vector? What about the line vector? This is the this if this is the curve line, how I represent this curve line through vector, then every moment I have a tangent vector. There is a set of tangent. How I can represent this curve line through position vector? If this is origin, then every point here will be connected through origin. Then this is called position vector. If this point is x comma y, then it is xi plus yj. Y is x square, xi plus x square j. But if I want to represent it through a line vector, length vector, means vector that will be along the curve, that is also possible. There are two vectors. One is position vector and one is length vector. To get the length vector must be in dy by dx because every moment dy by dx is different. Every moment y. If I take this point as y, then this is y by x. If I take this point as y, then this is y by x. If I take any point x comma y, if I say dy by dx, then at this moment, what is the tangent line? If I make the tangent line meet the x-axis like this, and then draw the parallel to it, then it will go and meet the origin. Then what is y by x? That is dy by dx. What is the difference between y by x and dy by dx? If this is the line, if I take any point here x comma y, then this is y and this is x. Okay, that is y by x. Means if this point connects the origin, then this is y by x. This is the slope of position vector. Dy by dx, if I talk, then at this point, take the tangent vector, tangent line, make it meet the x-axis, draw a line that will go parallel to it, and then it will meet the origin. What is y by x for this? Because if it is a straight line, everywhere y by x will be same. What is y by x for this line? This is dy by dx. Okay, if this point is x comma y, at this x comma y, I calculate the y by x for the line that is tangent of this line point. This line's y by x is dy by dx. But if this point, if I connect through origin, then this line y by x is y by x. So both are different. The y by x of tangent is dy by dx. Y by x of the position vector is y by x whatsoever. This line y by x is not constant, or dy by dx that is the tangent vector is not constant. I have to represent this vector. I have to represent this vector, and that vector representation must have dy by dx, because dy by dx is variable here. In that fashion, if I start with our vector representation as xi plus yj, I'll take out x, then it becomes I plus y by xj, bracket close into x. Now y by x, if it is a division I can transform into differentiation if numerator is dependent upon denominator. Yes, y is dependent upon denominator x, and x is only variable here. I can rewrite as dy by dx. It becomes I plus dy by dx j, bracket close into x. Now the first term I plus dy by dxj, it will be a function, vector term function in a term of x only, because y depend upon x. This is fx. Fx into x, fx into x will become fx into dx as per the concept of integral calculus. What do you mean? The representation of a curved line through vector is I plus dy by dxj, bracket close into dx. Then how I can represent any line through curved line? It is very simple. Get any point on the line and get the coordinate of that point. If you have a polar coordinate system, yeah, I have a polar coordinate system. What is polar coordinate system? That is any point in polar coordinate system. If I have a circle, if I have a circle, then if this is x-axis, if I have a circle, then this is x-axis. Any point here can be represented as x comma y. Okay, this may be x-axis here also, because we have seen circle. Circle can go anywhere. This is x-axis and this is y-axis. Okay, this is origin. This is a circle. This point is x comma y. But if I talk in polar coordinate system, then where the radius connect origin and the circumference, then this point is r comma r theta, where r is the radius, that is one component of the polar coordinate system, and r theta is another component, not theta, r theta. R unit vector plus R theta unit vector. How to calculate length vector? How to calculate length vector? Okay. Now, if I want to calculate length vector, then I have to take out independent component away from it. Like if I want to calculate length vector of this at x comma y, then I'll take out independent component from it. What is independent? X. Then it will become I plus dy by dx j, bracket close into dx. Now I'm trying to calculate area of this. Area of this. Area of this means the cross product area of this. We are trying to calculate area of this. Hop, hop, hop. There is a line like this and there is a line like this. What is area in this of these two? What is area of the in between this? Cross product of this and this vector. What is this vector? Any point I can take here x comma y. Here any point I can take here x comma y. That is what is the vector representation of this? Xi plus yj. What is vector representation of this? Xi plus yj. Okay, if I want to calculate the area, I have two independent components. Here in xi plus yj, I'll take out x as independent component. Here in calculation of y of this vector as a length vector, I'll take out y as independent component. What is area of this? Area is length vector cross product length vector. The way we said, what is area in between it? What is area in between it? This vector cross this vector. What is area in between it? What is the area? What is the area in between this? Then cross product of this vector and this vector. What is the vector representation of this? Okay, vector representation means if this point is x comma y and this is origin, then this vector position vector will be xi plus yj. I have to take out one independent component, that is x. Then it will be I plus dy by dxj bracket. I plus y by xj, bracket close into x. Okay, but you said that independent component along any curve is dy by dx. That is the minimum thing, the smallest thing that is changeable. If I want to represent anything through algebra, then you have to find the smallest entity that is varying. and based upon it everything is dependent upon. Then here for a curved line the smallest thing that is varying is dy by dx, not x. dy by dx. dy by dx is a concept that is varying every moment. That is the most variable component in a curved line. Where if it is a straight line, then the most most variable component in a straight line is x1. That's because dy by dx is constant. It is not varying. Only thing varying is x. With different x, you have different y. Y is dependent upon x. Makes sense. I want to represent this as a vector. Take point as this point is origin. This point is x comma y. What is vector representation of this? Xi plus yj. If y is a function over x, that is it is, then xi plus function over xj. Now this is represented through the minimum variable component, that is x. It is alright. Okay, what is the vector representation of this curved line? What is vector representation of this curved line? If this is a line, what is the vector representation of this curved line? Then what is this is x. With different x, we had different y. I know the variable is x. No, that is not the minimum variable. At every moment dy by dx is different. That is the most minimum variable here, dy by dx. You have to represent this vector through dy by dx. Then only you will get the length vector. Then I have xi plus yj. Take out x. It becomes I plus y by xj bracket close into x. If I can represent the division to differentiation if numerator is dependent upon denominator. I can represent two multiplication items into integral calculus if left part is dependent upon another part. Fx into x is fx dx. Fx by x is dfx by dx. This is how we proceed. If I have I plus y by xj bracket close into x, then it can be represented as I plus dy by dxj bracket close into x, where I plus dy by dx will be in x1 j. This is function over x into dx. So vector representation of any curve can be achieved by taking out primary independent component. If I have xi plus yj, in that x is independent. I take out x, and then it becomes I plus dy by dxj bracket close into dx. Okay, what you are trying to find? I am trying to find area of this to find the area of this in coarse term. Actually the actual term is to divide into n different parts. We will see that why there is a compulsion of dividing into n different parts. But anyway, let's take the coarse term in bigger way. In bigger way, if I have the vector representation of this and vector representation of this, I can take cross product to get the area. What is vector representation of this? Now I can say this is another line to get the area. Calculate the calculate the area. What is vector representation of this? This is xi plus yj. What is vector representation of this? This is xi plus yj. To get this as a length vector, I'll take out one independent component. So this will become I plus dy by dx, I plus dy by dx j bracket close into dx. This is the vector representation of this. What is vector representation of this? Okay, in that fashion, what I have to take out? Okay, then someone can say, yeah, I remember you divided it into n different parts, where each section is a rectangle. In one line, we have delta x and we have delta y. In one place, delta y is variable. In one way, x is variable. Okay, you remember very well. Now, if I say I want to find the area in between this, then what is the length vector representation of this? Then it is xi plus yj. Then I took out x, considering x is independent. I plus dy by dxj bracket close into dx. What about this? If this, then we remember that we did a n by m division. So one section was x is variable. Yeah. So one vector, length vector, I took out x. What from the other vector? Other vector you have to take out y, because y is another component for the area. Then it will become dx by dy, xi plus yj cross xi plus yj in a very abstract manner. First way, I have to take out x as independent. then it will become I plus dy by dx j bracket close into dx. This is called length vector. What do you mean by length vector? If I calculate magnitude of x, I plus dy by dx j bracket close into dx, it will give the length of this curve. Yes, it will give the length of this curve. How to calculate area vector? Take the cross product of these two. This is xi plus yj. This is how we start solving a problem. Start from the basic thing, xi plus yj cross xi plus yj. This is this is represent this is this is rep- this is represented through xi plus yj. This point is x comma y. This is represented through xi plus yj. This point is x comma y. Now we have xi plus yj cross xi plus yj as the area vector. First, I have to take out x, I plus dy by dx j bracket close into dx, cross product. Second, I have to take out y as independent component. It will become dx by dy, I plus j bracket close into dy. Then you do the cross product, you will get the area. Certainly, you will not get it. Because dx by dy is not possible. Dx by y cannot be written as dx by dy because x is numerator should be dependent upon denominator and denominator should be independent. Dx by dy y is dependent, x is independent. Dx by dy is not possible. Okay, means I cannot calculate the area through two length vector cross product to calculate the area. If I go by the vector, what is the solution? You have to think third part on which x and y are dependent. Means if I say third party is z, I think about one guy called z. What about xz, where z is dependent and x is independent? This fashion. Third guy, where z is dependent and x is independent, then I can take a vector that will be in xz, cross product another guy yz, where y is independent and z is dependent. Then I can describe it as dz by dx, dz by dy. Then I can do cross product. Then dz by dy is possible. Z by y can be transformed into dz by dy because z is dependent upon y. I am thinking about something else, z, which is dependent on y and which is dependent on x. X and y are independent of each other. But you said x, y and x are dependent. It's all right, but I'm thinking about the third thing, which is dependent upon both. Okay, God thought about it. If I talk about God, He thought about it. That's how 3D came into the picture. In 3D, Z is dependent upon X and Z is dependent upon Y. X and Y are independent to each other. If I'm trying to calculate area, then I have to get the length vector. This length vector, do the cross product. Calculating the length vector, here I'm considering dy by dx, where y, it is actually y by x transformed into dy by dx because numerator is dependent upon denominator. Denominator is independent. Similarly, if I want to take out this as a length vector, then I have to take out y as independent. Then it will become x, y, y. But I cannot take x, y, y as dx by dy. In that case, x has to be dependent on y and y is, that is not true. That's why we need parameterization. Parameterization means we think about a third component. V is dependent upon x and y, and x and y are independent. Now we will have two different vectors. One is xz vector, a length vector that will be in variation of x and z. A length vector which will be variation of y and z. What do you mean? I will have dz by dx, I will have dz by dy. Then I will do cross product to calculate. Then it is not possible. Here I want, this is x-axis and this is y-axis. This cross product I want, but what are you thinking about z? But we have to think. Because this cross product of two vector will not give the area. Because length vector will not be formed because of the dependency nature. That's the reason we come to a concept of parameterization. That's the reason we come to a concept of theta. If I have x and y, then why we come to concept of theta, that is a different coordinate system. Why we come to concept of z, that is different. Theta is dependent upon x. Theta is dependent upon y. I can have something in theta x d theta by dx. I can something in theta y d theta by dy. Then I have two vectors. One vector is d theta by dx. One vector is d theta by dy. I can take cross product, whatever it gives. Okay, we will talk more in the parameterization, but I believe it is understandable now that two length vector gives the area underneath it, but two length vector cannot be created when one can be not be created in the concept of orthogonal component x and y where one is dependent and one is independent, because each length vector needs one independent component because we have to do y by x or x y y. X Y Y is not possible because X Y Y cannot be transformed into differential calculus, not possible. Okay, because numerator is not dependent upon denominator. Denominator is dependent upon numerator. Okay, we will proceed in this. These are very deep discussions. After all, you have to understand width and height of the intricacies of mathematics. Why Z is into the picture. Why R theta is inside the X and Y. Why these are the third party that are inside them. I could have calculated by doing the cross product of these two X and Y to get the area. Why I am doing with dp by dx, dp by d theta, dr by d theta, dz by dx, and so many things just to calculate the area one. Okay, what about the calculating the length of a vector? Then only you need one independent component. Then dy by dx is enough. You don't need two vectors to get the length. You need only one vector. Then it is okay. Please do not mind supporting us. +91 is the India country code 9483160610 is the telephone number. +91 is the India country code 9483160610 is the telephone number.